I think that your problem, and it's the same problem with nearly everybody, actually,
Mm.
is that nobody's ever taught you any exam technique.
No,
Okay,
especially
so
physics.
right, if I say to you, um, exam techniques, right? Papers, I mean, they're obviously question papers, but don't think of them as question papers. Think of them as instructions on what to write. Okay. Now, you can only do that if you understand what the question is properly asking you to do, right? So,
Mm.
if you, for example, understand the meaning of the word explain. So, which questions caused you most grief? I mean, were they the wordy questions or were they the calculate questions?
A bit of both, but some of them were when it was like explain compared to describe.
Mhm.
Sometimes I'd have to explain a little bit, and the mark seems so weird normally.
Yeah,
And it
except
was,
that they're
yeah,
not. They're not. They're really not. Okay, so I'm going to say
take
to
away.
you, there's a thing called, I call it command word scaffolding,
Yeah,
right? So there are some command words that come up all the time in A-level physics. I mean, top of the pile is calculate, right? But there's a family of command words that all of them mean calculate. So determine is a calculate, show that is a calculate, derive is a calculate, deduce is a calculate, right? Nearly always there's calculations involved in all of those command words. Okay, so there's calculate comes top of the pile, but second on the list is explain. And most people, ooh, I get coffee. Thank you very much.
like that.
Thank you. Thank you very much. Mm.
Yeah. Why didn't they just say calculator then?
Right, okay, exactly. Right, okay. Right now, you're a mathematician, right? You've done maths, you've done chemistry, you're physics, you're numerate. You're very numerate. You're also really bright, okay? Because you got a C even though you only did 4 or 5 papers, right? In physics.
Mm.
And you got a B in your maths. Honestly, you are really bright. You're right, top 5% of the country. Seriously, already, right? Seriously, you're really bright, right? And you're used to looking for patterns. You look for patterns in numbers all the time. You can't help
Yeah.
yourself,
That's
right?
why that's why I did good in maths with minimal
Yeah,
revision, but I
yeah,
know I can get an A.
absolutely, right?
Maths
Okay,
is so easy. Few questions, I could just repeat it.
mm,
Done.
okay, right now. The only difference, right? Physics is applied maths. The only difference is that in physics you have to deal with freaking words, right?
Yeah.
Isn't it? Right. Now, what I want you to do, you can do this, you can do that, you don't need me. You can do this. You can look for patterns in the words. Okay. So sometimes it's calculate, sometimes it's determine.
Yeah.
Right? And it might be calculate the speed of the car at t is 2 seconds, or it might be determine the speed of the car at 2 seconds. When do they say
Yeah.
determine instead of calculate? Right? And I promise you, it's in a very specific situation.
Graph.
Yes, that's it. Right, you need a
Mm.
graph, right? Determine is always, you've got to get some of the numbers, maybe only
Yeah.
one, but sometimes it's
In
more
some place
from the
else.
graph, right? So if it's determine the speed at t is 2 seconds, it might be a distance time graph. So you have to draw the tangent to the curve at t is 2 seconds, right? And then you get your gradient, right? From the graph. So can you see your determine? And the
Yeah.
word determine and graph, they are so intimately linked with one another that sometimes they use the word determine even when you've got to provide the freaking graph. Right,
Mm.
so those horrible describe an experiment to show questions, those ones,
Yeah.
sometimes it says in the question, include in your answer how you will use your results to determine, I don't know, the spring constant of the spring or whatever. Can you
Yeah.
see that you'd say, right, well, I'm going to plot force extension and the gradient of my line is going to be my spring constant? Can you see you've provided the graph?
Yeah.
Right, so
Yeah.
determine always goes with graph. So when do they use show that and then give you the answer? Why would they
So
do
like this is when you're like deriving equation and then okay, they give you the answer.
that? So sometimes it's calculate, I don't know, the energy of the electron, right? Whatever. And then sometimes it's show that the energy of the electron is, and they give you the actual answer. Or it's about, and they give you something that's really close. Why
Oh
would
yeah.
they do that?
Is it because the one used to do a separate calculation and explain like what's going on there to
You'd
leave you?
think, wouldn't you, that it would all be about, showing you're working and all that rubbish. It's not. It's really pragmatic, okay? It's because examiners are lazy,
Right.
right? So there's a rule in exams, public exams, that says you're only allowed to penalise a student for one mistake once. So if imagine if you had a calculate question and you
Yeah.
calculated the answer wrong, but
Yeah.
then you had to use that answer in the next bit. So it was calculate the energy of the electron, and then it says calculate the speed of
Yeah.
the electron. Right? But if you've got the energy wrong, then you're going to get the speed wrong, aren't you, for the half mv squared?
Yeah.
Right? So, and in that circumstance, they can't penalise you for getting the speed wrong because they've already penalised you for getting the energy wrong. And you just used the wrong answer correctly in the second bit. Right? So they're not allowed to do that. So they have to do something called an error carried forward.
Yeah.
Right, now the examiners hate that. The reason they hate it is because if you make a mistake calculating the energy of the electron, then it could be any number, right? Which means that they actually have to use your number in the calculation and work out whether or not your second answer was right, but with your wrong number. It makes them do the sum themselves,
Right.
right? And they don't want to do it. It's too much effort. So they
Yeah.
instead of that, what they do is to show that. And then they give you the answer. And then if you use the wrong number in the next bit, then you've made a second mistake. Your second mistake is that you used the wrong number. Right? And they're
Yeah.
allowed to penalise you for that. So they didn't have to do an error carry forward. But, what does it say from your point of view in the exam? If you've got to show that and they've given you an answer, you know you're
Oh
going to be
right.
using that in the next bit. That's a
Yeah.
huge clue. It's like neon sign, bruh, bruh, bruh. You're going to be using this. Look at
They
this.
do,
Look,
they
look,
do at
look,
the
look.
same time.
How
Yeah.
useful is that?
Yeah.
Right now, and that's the sort of pattern recognition that you've got to get your head round, right? Now, those are just a couple of examples. I mean, I was talking about the structure of your answers as well. So all explain answers have the same structure. In
Yeah.
the history of the world, in every subject, explain has the same
Yeah.
structure. And you said, oh, but they all seem a bit weird. And I bet you end up writing a load of stuff and you just like hope that you're going to say the things that are going to be on the mark scheme. Yeah?
Yeah.
And in fact, if you understand the structure of explain, you can pinpoint them. You can predict. You can say in a 3 mark explain, I've got to say that, I've got to say that, I've got to say that. And lo and behold, those are the 3 things that are on the mark scheme. And you're
Yeah.
going to me, what? Can you really? Can you really? And I'm like, yeah. Okay, so the structure, are you ready? Write it down. The structure of explain. Do you know it? Can you do it? Do you reckon?
Mm, uh,
It's really simple. Are you ready?
it's,
It's key fact,
right.
consequence.
Really?
That's it. So,
Even for
right now,
EQA?
sometimes it's more than one key fact, and sometimes it's more than one consequence. But that's the basic structure. And of course, in physics, a key fact can often be an equation. So, for example, explain why the car accelerates. And you go, well, F equals ma, and F is not 0. So A is not 0. Right now that is really trivial. Okay, no context, no right. So normally in these explanations I do something that's a little bit more sort of wordy, like, okay, because explain is often words, right? So your mum says, whack up, explain why your bedroom carpet is wet, right? And
Oh,
you go, well, mum, okay. And here is the explanation, okay? So you have, I mean, if you're explaining why something's wet, your starting point, your key fact, is not the fact that my front door is white, which it is, but it's irrelevant, right? It's got to be the right key fact, okay?
Yeah.
So in the case of explaining why something's wet, it's really you've got to explain what's the source of the water. That's going to be the starting point, isn't
Yeah.
it? And so you go, well, mum, there was a glass of water on my bedside table, and that's the key fact. That's a
Mhm.
mark, right? And then there's a second key fact in this explanation. Are you ready? You don't know this, but you've got a cat called Derek.
Really?
Yeah. And you can see where I'm going with this, can't you? You say, well, mum, there was a glass of water on my bedside table and Derek got in my bedroom. Right. And Derek did what cats do. Right. And the consequence was my glass of water was knocked off onto the carpet and now my carpet's wet. Right.
That's two facts, one consequence.
Yes. 3 mark explain. There could be a second consequence. Instead of asking you why your bedroom carpet's wet, your mum might have said, Wacko, explain to me why my socks are wet and all I did was walk across your room.
Yeah.
Like, can you see bedroom carpet's wet? And now the consequence of the consequence is that there's water on your socks, right?
Yeah.
So now can you see the structure though? And if you
Yeah.
know that structure, suddenly it becomes, well, actually, if I'm going to explain this, there is a very correct and only starting point. Right. There's an explain. I mean, they never say it. Explain pressure. It's kind of like explain what happens to the pressure when you move the gas bottle from a cold room into a hot room or something, right? But it's basically it's explain pressure, right? And you have got to figure out what is your key fact. So if you're moving a gas bottle from a cold room into a hot room, and they say explain why the pressure goes up when you move your gas bottle from the cold room into a hot room, what's your key fact? What's the starting point? What has changed from one to the other? Where are you going at? Where are you going to hang your hat? That's the explanation upon which the rest of everything hangs. What's the key thing that's different in the cold room compared to the hot room that causes the temperature, the pressure to go up, right? So thinking about kinetic theory, thinking about what produces pressure in the first place. Why is there a pressure on the wall inside my gas bottle? What has
Because
to
uh, there has to be obviously collisions. Obviously, if it's less hot, less kinetic energy.
happen? There you go. Can
Right.
you see your starting point? Your starting point, you've just pinpointed it, is
Mhm.
that the particles are moving more. They're faster.
Yeah.
They've got more kinetic energy. Can you see? I mean, yes, you could say they're moving faster or they're moving more or they've got more kinetic. Can you
Yeah.
see? But the bottom line is that your key fact, your starting point for explaining about pressure changes has got to be based on the motion of the particles.
Yeah.
And yes, you might say the velocity is more, or yes, you might say that the kinetic energy of the particle goes up when it gets warmer. But basically, that's the starting point. Can you see? You've pinpointed it, right? And the
Yeah.
consequence of that is what? And I mean, pressure is you're looking at a 5 or a 6 mark explain. So you're talking about more collisions with the walls, and the collisions are harder, and so your momentum change is bigger. So the force on the particles is bigger, and Newton's third law says there's an equal and opposite force on the wall, and pressure is force over area. That's another key fact. And so, can you see? You can end up going. Can you see? It's sort of stacking this key fact
Yeah.
consequence. But if you've got your starting point, you have to say that. 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 Oh, lo and behold, those are the 5 points on the mark scheme. And
Yeah.
suddenly it isn't vague, it's absolutely clinical. And you can kind of go, well, I've got, yeah, bam, 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 if you know the structure of explain.
Mm.
Right, so calculate's top of the list, explain is second, third, describe.
Describe.
Mm-hmm. So, how do you describe something? What does it mean to describe something?
Describe and explain. I always get confused with that. Describes like state what's happening.
Yeah, it's say what you see. Or what you would see with your mind's eye if it's about electron energy levels in atoms. I mean, you can't see that; it's too small. But if you could see that, you'd say what you would see, right?
Yeah.
Easy, yeah. Except that nearly every describe question that's 2 or 3 or 4 marks, people lose 1 or 2 every time.
By explaining.
Well, yes, sometimes they explain because they don't know the difference between explain and describe. But sometimes it's just because they don't describe thoroughly enough. Right.
Yeah.
Imagine that you had a question about stretching a spring. Right. So it's Hooke's law, right? And it's a straight
Yeah.
line through the origin, force against extension. Really straightforward, right? And the questions is a 2 mark explain. Sorry, a 2 mark describe, get it right? Right? Describe the relationship between force and extension for this spring. Right, and they've even given you a graph, and it's a straight line through the origin. They've given you the graph and everything, and you've got to describe the relationship. Describe. What would you say?
There's a graph and describe. So I'll say what happened from point A to point B on the graph, and I'll say what happens on the next part of the graph. I'll
Well, it's a
just
straight line through the origin. So, which what? I mean, there aren't points A and B on there. So, what would you?
yeah.
How would you describe it?
I'll just say, oh, it's linear and
Linear, good.
constant acceleration.
It's not acceleration; it's force extension.
Oh, force extension. Oh, right, right. So it's like directly proportional.
Good. Okay, so F is directly proportional to the extension. Yeah.
Yeah.
Yeah. Okay, that's good. That would get you one of the two. Right now, this is what I mean. People describe, but they don't describe everything. Right.
Yeah.
So I want you to imagine, Waka, that you have your twin. There's another Waka, Waka two, right? He's sat with his back to you, right? He's just as intelligent as you are, brain size of a planet, right? Brilliant, brilliant guy, right? And your job is to describe the relationship between F and E for the straight line through the origin. That relationship so well that Waka 2 can draw the graph without ever looking at it.
Right.
So you've told him it's a straight line through the origin, but a straight line through the origin might look like that, it might look like that. He can't reproduce the graph unless you give him one more bit of information.
Right.
And the extra bit of information is what? Can you see? You've got to give him the gradient of the line, or at least one point that the thing goes through.
Yeah, yeah, yeah. So
So can you see that describe doesn't just mean say what you see,
yeah,
it's say everything that you see, including numbers.
including numbers. Right. So going through zero. Well, it has to be going through zero for direction
Yeah,
forward.
so it's directly proportional. It has to go through zero. So you need one more point. Can you see that's all you need? And then it would be a
Yeah.
complete description. Because Whacker 2 would be able to reproduce the graph perfectly.
Positive. Positive.
Now, can you see that when you're
Yeah.
doing one of those describe and experiment to show things, if you couldn't follow the instructions that you've written down, your description is not good enough.
Yeah.
Can you see that describe now? Now you can follow a describe, can't you?
Mm.
So and your question paper is no longer a question paper. It's a list of instructions on what to write.